Hello student, we have already discussed about the various modulator and the various amplifier which can be used for the optical communication and photonic integrated circuit when we are getting the less strength optical signal. For that, for improving the optical signal, we need a fiber amplifier, right? So we have and this today's class we will discuss some portion of the terbium fiber amplifier and the Raman fiber amplifier. There are based on the application, we sometimes we use iterbium fiber amplifier. Sometimes we use the fiber Raman fiber amplifier, right? So here, in case of the if we want to design the iterbium doped fiber amplifier, okay. So there you can see there are the three structures. This is one structure. This is one structure. This is one structure. This is another structure. Okay. So so now you can see here. Sorry. So in the left side diagram, you can see there are the three diagram. One is the one pump laser error you can see. In the second one is the pump laser error from the right side, and the third one is the both side pump laser are feeding. Okay. Now that means you can see there is a co-directional pumping, another is the counter directional pumping. Okay, counter directional pumping. So here in the second diagram you can see this is the second diagram. In the second diagram, the right side we are giving the pump laser. In the first diagram, left side we are giving the pump laser. When we are giving the right side pump laser, that is counter directional pumping. Counter directional pumping means the signal is flowing from the left side direction in the second diagram, but you are giving the your pumping laser and your pumping wavelength you are giving from the right side of the second diagram. So that is counter directional coupling. And the top diagram you can see that from the same direction we are providing the signal, and the same direction we are providing the pumping line. So both are in same direction. So this will be the co-directional pumping. And so normally we can design the bidirectional pumping also. In this the last diagram, the third one and the fourth one, here you can see the pump we are giving here, and then the right side both direction we are giving the pump, and the signal is coming from the this side to this side. Okay. And for the counter, this is the counter directional coupling. We are getting the higher gain as compared to the co-directional coupling. This is the co-directional coupling. Signal same, both are in same direction. So there are some advantages and disadvantages in case of the Iterbium to fiber amplifier. And the advantages normally whatever signals the C band and L band we are providing, those both C band and L band are commercially available, and we can get the higher gain from the Iterbium fiber amplifier, as well as the there will be no distortion at the end. We can get the higher bit rate, or bit rate also. And the drawback, if I think about the drawback of the this turbo fiber tube, the pump laser normally required for case of the some equalization is required, and it's difficult to integrate for other. If you want to integrate with the other component, with certain it will get you will get difficulties for that. Now we come to the fiber Raman amplifier. Fiber Raman amplifier, it depends, totally based on the scattering. One is the spontaneous photon scattering, another is the stimulated photon scattering. And this kind of the wavelength, for that we can provide it to different way. We can provide, or the two different kinds of the wavelength can be incident on the device for this case. And Raman scattering is also known as the elastic scattering. So in the this diagram you can see right hand side diagram. So this one, okay. So this is the H nu one, this is the H nu two, and this is the H nu p. So H nu one, this we are providing. This is the incident wavelength, or pump wavelength we are providing into the device, and it will go from the ground state to upper state. Okay, to go from ground state to upper state, and after that, and at the same time you can see some electrons are going from the ground state to and the vibrational energy state. Vibrational energy state means there's some discrete energy states where this there will be a vibrational transition when the molecule will be vibrate. When the molecule will vibrate, there will be a vibrational transition between this vibrational transition level. Okay, so these are the vibrational transition level. So electrons are going from this level to higher state, and the electrons are going from this level to this state. So after that, after some time, the electrons will probably come from upper energy state to this lower the vibrational energy state. You can see. So this is the H nu. We are getting the H nu. Okay. So this h nu is the less than about the h nu 1. In the equation you can see the V2 is equal to V1 minus Vp. That means the scattering wavelength is less than the incident wavelength. So this is called the scattering, which not totally depends on the population inversion. So the way you are giving the pumping, so first it will go from ground state to upper state. After that, from upper state to this the vibrational energy state it will come, and it will provide a scattering, this light scattering. Okay, and due to this phenomena, so normally in the device also there will be a molecular vibration. How due to the molecular vibration, the modulation index will be changed. Okay, so when excited wavelength will trying to go from the ground state to upper state, and there is a vibrational state. Some electron will go to upper state, and some electron will go to the vibrational state due to the molecular vibration. Okay, due to the molecular vibration, there is a change in the modulation index of the device. All right. So due to that, when some photons fall back from the upper state to ground state with a frequency lambda 2, with the frequency nu 2, due to the change in the reflective index, those the nu 2 light will be scattered from the device, and it will emit a scattering light. So this is the fiber Raman amplifier, the scattering mechanism. Okay. Now, two different scattering mechanisms are available. One is the stroke scattering mechanism, and another is the anti-stroke mechanism. In case of the stroke scattering mechanism, the scattering wavelength light that will be lower than the excitation light wavelength. Okay. And in case of the anti-stroke, the scattering wavelength light will be higher than as compared to the excited wavelength. So in this two diagram, you can see one is the stroke diagram, one is the anti-stroke diagram. The new one is the in the stroke diagram. The new one is the incident wavelength, and the new two is the excited the scattering wavelength. Due to the vibration, with the help of the vibration and energy, the new two is less than the new one. The anti-stroke, the excited wavelength is greater than the incident wavelength. The emitted wavelength is the scattering wavelength is greater than the incident wavelength. The new here in the right hand side diagram also new 2 is the scattering wavelength which is higher than the new one. So two different way based on the mechanism, two different way we can divide the scattering frequency. One is the stroke scattering, another is the anti-stroke scattering. And apart from the two different phenomena, the spontaneous Raman scattering and is the stimulated Raman scattering. So when we are giving the low intensity light, the whatever light is scattered from the device, this light will be non-directional. That's why the name is the spontaneous Raman scattering. And when we are trying to provide a higher intensity light, okay, so this will give a stimulated Raman scattering. So all the light which is scattered from the device, all the light will in phase in direction. Okay, and so as higher intensity light is entering into the device, so the modulation index, that there is a different kinds of the change in modulation index. Due to that the phenomenon, and why it is happening, again the vibration, and due to the vibration only this entire thing is the scattering phenomena is occurring. So we are getting all the light in frequency scattering. So all are in directional and the in phase for case of this stimulated Raman scattering. So if you want to achieve the higher gain, better if we use the stimulated Raman scattering as compared to the spontaneous Raman scattering. And there will be some side effect. There is the disadvantages. The dispersion phenomena used to happen in case of the fiber Raman scattering for stimulated Raman scattering. Okay, so how can you achieve the stimulated Raman scattering? So here high intensity light would be provided. So we're combining the various intensity of the light. You can see in this diagram the various intensity light we are providing. Both are combined into a combiner, and we are getting the one broad intensity light, and this will be also high intensity. So this light is entering into the coupler along with the transmission fiber, and both the due to the this interaction between this transmission line and the coupling, the pumping light, so we're getting the higher intensity light here. Here if we're providing low strength in the left hand side, and the input side or the output side, we can get the higher intensity light. Okay, so this we can arrange the pumping mechanism in case of the fiber Raman amplifier for achieving stimulated Raman emission. Okay, so you can see the different wavelength 430, 450, 470, and the 490 nanometer wavelength we are providing. This consists of the diode laser array. And like similar to 8 to fiber amplifier, we discussed that the two different way you can provide the pumping. The same in the same way in case of the fiber Raman amplifier also forward pumping and the backward pumping. By name also you can understand that if the signal wave and the pumping wave are in both the same direction, this is the forward pumping. In the signal wavelength and the pumping wavelength both are in the different direction, that will be in the backward pumping, and both are we are providing the forward pumping and the backward pumping, both will the mechanism is known as the bidirectional pumping. Okay, so these are also required. How what kind of the pumping we'll use? So this mainly depends on the application of the fiber or Raman amplifier. So that means I want to conclude that the determinant fiber, apart from the determinant fiber amplifier and the fiber Raman amplifier, there are lots of fiber amplifier which we can modify the fiber mechanism, and we can achieve the various high gain from the fiber, right? So this total the unit 4 are related to modulator and pumping. Modulator means the entire property of the light we can change. The amplifier means the intensity of the light we are changing. So various, so we can change this thing. I am going to bind up this the unit 4 portion of the optical fiber communication. Please, if you need anything, you just comment, write on the comment section, and please like, share, and subscribe my channel. And thank you.